Okay, so today we're talking about adding and subtracting rational expressions. So again, adding and subtracting fractions. So first we need to remind ourselves how to do that. So make sure you answer the question about what you need to do to add and subtract fractions. So if you remembered correctly, in order to add and subtract any kind of fraction, they have to have common or like denominators. So it's the same way as if I was to add or subtract terms together. They have to be like terms. It's the same thing as if I was to add and subtract radicals together. They have to be like radicals. So in order to add or subtract things, they have to be like or common. So in this case, these denominators are the same, which means I can just go ahead and combine them and add or subtract right across the top. And the denominator will stay the same. That's why it had to match. So I would do a 5 on the bottom. So if I have 2/5 and I take away 3/5, I have -1 left because I do 2 minus 3. If I can, I would simplify this. So now here, these match. They're like terms. So I would add across the top 8 plus 2, which is 10. Now I'm going to check and see if it reduces. And if you type this in your calculator, you end up with 2 over 3. But let's talk about why that actually is. So 10 breaks down into 2 times 5. And 15 breaks down into 3 times 5. And then 5 over 5, just like simplifying our rational expressions, cancels. And I'm left with 2/3. That's why 10 over 15 reduces to 2/3. So let's do it with polynomials, or these rational expressions that we have. First, we have to see if it's asking us to add or subtract, do these match? And they do. So again, the bottom is going to stay the same. So you're just literally adding across the top. So the top technically looks like x minus 3 plus this whole thing, 2x plus 18. So now I'm going to see, can I make that any simpler? And I can. I can combine like terms. 1x plus 2x is 3x. And then negative 3 plus 18 is 15. And the bottom, again, was x plus 5. So now I'm going to see, can I simplify this any further? So now I'm going to go back to my simplifying process that I had before. So first thing to check is to see, is there a GCF up here? And I can take that out. And I'm left with x plus 5, which doesn't factor any further. And then I had this other x plus 5 on the bottom, because that denominator doesn't factor. So x plus 5 over x plus 5 actually cancels, and the whole answer ends up being 3. So it goes from this really ugly expression to 3. Also, don't forget that if you're going to do domain and range, you would do it up here before you cancel. So all of that stuff is in the domain. Right here. So then we're here. Let's talk about this one. Again, these match. So that stays the same on the bottom, 2x minus 1, which means I can go ahead and combine across the top. 4x squared minus 1. And I can't combine any like terms, so that's what it looks like. Now I'm going to see if I can simplify it. So I'm going to check and see, can I factor this top? And I can. It's a difference of squares. So I'm going to take the square root of the front plus or minus the square root of the back. That's what this is factored. I meant to do that in red. And then this bottom part doesn't factor. That won't always be the case. Sometimes it can factor, but in this case it doesn't. And so now I'm going to cancel what I can. And I can cancel 2x plus 1 over 2x plus 1. So my final answer is left with 2x minus 1. So how do we add fractions when the denominators are not alike? So in order to do that, I have to find what's considered a common denominator. So it would be a number that I can divide evenly by, in this case, 15 and 5. So it'll be real easy if I can take this and I can turn the 5 into a 15. See, technically 15 is 5 times 3. So this term is actually just missing a 3. So in order to do a common denominator if I multiply this side by 3, and I have to also multiply the top by 3. So now when I do that, this has become a 15, which is exactly what I wanted. And then 8 times 3 is now a 24. And I can check that. I can type 24 over 15 in my calculator and reduce it and find out that I do get 8 over 5. So I can always check that answer. And then this was already a 15. So that 6 won't change because it already gives me that. So again, I'm just rewriting this fraction. I'm not actually changing it. It still represents 8 over 5 because if I was to reduce it, I would get 8 over 5. I just want the bottom number to be the same on both of them, so I had to manipulate it a little bit. So now that they do match, I can add across the top. 24 plus 6 is 30. And again, this bottom number stays the same. And then I reduce if I can. And I can reduce this to the whole number 2. So same here, I need to make it match. So technically this is 6 times 3. So I could just multiply again the top and the bottom by 3. It won't always be 3. It just happened to be in the 2 examples that I chose. So this one will be 18 now on the bottom, which is what I wanted. And then 3 times negative 1 is negative 3. This one was already an 18 on the bottom, so I can leave it alone. And then I have the 5. So now I'm just going to leave the bottom 18 because they match. And then do negative 3 minus 5, which gets more negative, which is negative 8. If I can, I am going to reduce it. And in this case, I can. So I end up with negative 4 over 9. So let's do that with rational expressions. So again, they don't already match. But what would this need to make it match that? Well, this one has a 3 in it already, so to make a 3 and 9, I could just multiply this one by 3. And to make an x and x squared, I can multiply it by x. So if I multiply 3x times 3x, do I get 9x squared? Yes, so that would work. But don't forget what you do to the bottom of the fraction, you also have to do to the top. So I get 3x times 2, which makes this term 6x. And then I get 3x times 3x, which is a 9x squared. And again, I don't have to change this because now if I leave it the same, these already match. So now I can follow the same steps I was before. It's the exact same as if it was like denominators. So again, the denominator stays the same. And then I just add across the top, 6x plus 5. There's no GCF in this, so there's no way to factor it. And I cannot reduce this, so this ends up being my final answer, simplified. So when I'm looking at this second group, I'm trying to figure out what's missing. But before I can know what's missing, I have to know what this actually is. So I'm going to see, can I break this down? And instead of an x squared minus 9, it's a difference of squares. So I would write the square root of the front plus or minus the square root of the back, which is 3. So actually, this denominator is an x plus 3x minus 3. So in that case, because this one already has an x plus 3, well, what is it missing? It's missing an x minus 3. So for this one, I'm going to multiply, it's already got an x minus 3, so I'm going to multiply the top and the bottom by x plus 3. And that will take care of what's missing. And you can leave it broken down here because you're going to just have to break it down again when you simplify anyway. So now that I do that, this first term already had everything it needed. So I'm going to write it as 3x plus 21 over the factored x plus 3, x minus 3. So I haven't really changed anything. All I did was factor the bottom. On this one, some things did change. Again, it was missing the x plus 3 to match this one. So I had to multiply the top and the bottom by that. So I'm going to leave it as this x minus 3 and x plus 3. And it doesn't matter which order they're written in, that technically still matches. And then now I've got this negative 5 here. That's going to be multiplied to x and 3. So this actually becomes negative 5x minus 15 because I would distribute that there. Okay, so again, I went ahead and changed this to a plus negative, and I distributed a negative 5 to both of those. so that I didn't have to worry about changing my sign again later. It just makes my life easier. So now that those match, which they do, the denominator stays the same, x plus 3, x minus 4, because they're the same. And I'm just going to add across the top. 3x minus 5x is a negative 2x. And then 21 minus 15 is a negative 6. I'm sorry, is a positive 6. 21 minus 15 is a positive 6. So now I'm going to check and see if anything cancels and it can be simplified. So while I'm looking at that, I'm going, well, nothing cancels. But, yes, this is already factored, but I haven't factored my numerator because I didn't know what it was. So there is actually a GCF that I can take out of here. I can take a negative 2 out of both of those terms, and I would take a negative because my front number is negative. And I end up with positive x minus 3 in parentheses. And then on the bottom, which didn't change because it was already completely factored, I have x plus 3, x minus 3. And these cancel. So my final answer is negative 2 over x plus 3. Simplified.